Hello everyone, I'm Satria Nur Ramadhani. Before we begin, let me ask you something simple. Have you ever noticed how fast things grow when they double, triple, or multiply repeatedly? For example, the number of bacteria in a bottle, the way viruses spread, how many grows with interest, how technology speed increases every year. These all grow exponential. And today we're going to dive into a topic that's super common in math, powers and roots. Explain exactly how that works. So let's explore this together step by step with clear explanations and real life examples so everyone can understand it comfortably. What the powers? A power is a shortcut that tells us how many times we multiply a number by itself. When you see something like 5 squared, it simply means 5 times 5. In general, a to the power of n means multiply a by itself n times. The formula is a to the power of n equals a times a times a n times. For example, 3 to the power of 3 equals 3 times 3 times 3 is 27. In real life connections, it's like bacteria doubling 1, 2, 4, 8, 16, or folding paper. A sheet folded 10 times becomes 2 to the power of 10 thickers. In powers, there are 5 properties. The first is same base. Add exponents. If the bases are the same, we just need add the powers. The formula is a to the power of m times a to the power of n equals a to the power of m plus n. For example, 3 to the power of 3 times 3 to the power of 2 equals 3 to the power of 5. The second is division, subtract exponents. The formula is a to the power of m divided by a to the power of n equals a to the power of m minus n. For example, 6 to the power of 5 divided by 6 to the power of 3 equals 6 to the power of 2. Next, the third is power of a power. The formula is a to the power of m n equals a to the power of m times n. For example, 2 to the power of 3 squared equals 2 to the power of 6 because 3 times 2 is 6. 2 to the power of 6 is 64. The next property is zero exponents. The formula is a to the power of 0 equals 1. Any number as kept 0 raised to the power of 0 equals 1. For example, 9 to the power of 0 equals 1, or 21 to the power of 0 equals 1. Okay, last properties of powers is negative exponents. Negative exponents means flip the number. The formula is a to the power of negative n equals 1 a to the power of n. For example, 4 to the power of negative 2 equals 1. 4 to the power of 2 is 116. The next material is roots. What the roots? A root does the opposite of a power. So basically, the square root asks, what number multiplied by itself gives this number? For example, square root 64 equals 8 because 8 times 8 is 64. In real life connections, it's like area of a square. If you know area 49m squared, side square root 49 is 7m. Or construction, to find side length from total area. In roots, there are three properties. The first is roots over power. The formula is square root a squared equals a. For example, square root 7 squared equals 7. The second property is root over multiplication. The formula is square root ab equals square root a times square root b. For example, square root 20 equals square root 4 times 5 equals to square root 5. Okay, last properties of roots is root of divisions. The formula is square root ab equals square root a square root b. For example, square root 49 16 equals 7 4. How solve powers? When solving powers, think like this. How many times do I need to multiply this number by itself? Step 1. Look at the base. Step 2. Look at the exponent. And step 3 is multiply step by step. And how to solve roots? When solving roots, ask yourself, what number multiplied by itself give this result? For example, square root 121, what number times itself equals 121? Is 11. Powers and roots are everywhere in daily life, from technology, biology, finance, engineering to simple things like measuring shapes. Once we understand the rules, they become tools that we can use confidently. Keep practicing, and these ideas will feel natural. Bye bye!